Hello, this is AJ Holtz. I'm an engineer with Gates at the Brandon location, and I would like to show you a spreadsheet that I created. Initially, I made this just to help me get a better understanding on the math behind bent tubes. And at the same point in time, I was teaching myself some of the macro programming side of automating Excel functions with Visual Basic code. As a result, this spreadsheet developed into a pretty useful tool. Here's an overview of the spreadsheet, and for user inputs we have our X, Y, and Z coordinate columns, as well as the tube diameter, the centerline bend radius, and the tube wall thickness. The spreadsheet then calculates the straight section between the bend tangents, shown here, the bend angles, shown here, and the rotation between the bend planes. I just have the one rotation modeled here. The calculations can get pretty complicated for the rotation between two bend planes, but I had some fun proving it out. And there are a lot of cells hidden here where the actual math is going on. I added a couple of options buttons for inches and millimeters, so whatever units the customer provides can be entered into the columns, and the spreadsheet will automatically convert between the two. There is also a reverse button that, when clicked, recalculates the coordinates to have the origin start from the other end of the tube, as well as the Update Views button, which adjusts the front, right, and top views down below. The views are a good visual check for the user to see if the coordinates typed in create views that match those on the customer print. The sheet is also conditionally formatted to warn if either the bend angle is less than 5 degrees or the straight section is less than 2 times the outside diameter, which are both general rules of thumb for tube manufacturability. Switching gears here now to the tube generator portion, Desk Inventor also has a VBA editor, which I use to write a macro to read data from the XYZ sheet and generate a tube model. Notice when I click the tube generator button at the top of the screen, it creates the 3D tube model instantly. Now there is a lot going on here in a fraction of a second, so allow me to step into the VBA code quick. The macro starts by plotting each coordinate point in its 3D space based on its X, Y, and Z value, and then connecting all of the coordinate points with a 3D sketch line, with the intersection points having the bend radius, which is read from the spreadsheet. And then on the end of the tube, a plane is created, and on that plane, a 2D sketch of the OD is drawn, which is also read from the spreadsheet, and based from the wall thickness on the spreadsheet, the ID is also sketched, and then that cross section is swept over the 3D sketch to create your tube. Now, just for fun, let's see how Tube Generator handles this 20 coordinate tube with 18 bends. So I'll go ahead and click this top macro button again, and as you can see, all 20 coordinate points instantly plotted and swept to create the tube. Generating instant tube models eases the process of checking for machine interferences during bending and saves a lot of time when modeling test fixtures or jigs. Well, at this time I'd like to thank everyone for watching, and please reach out to me if you have any questions. I would love to hear your feedback.